I've cleaned up the existing builders again so that they're all split into partial classes. So let's build our build method. If we examine the build method of an existing builder like Country Builder, it's apparent that we're going to need to iterate through the type's properties. We're going to need them multiple times actually, so let's just pull them into a variable here at the top of the loop. We'll get the properties of the type, and we're only interested in the public instance properties that we can write to. And then we'll sort them by name and output them to a list. Rather than nesting a bunch of loops, let's call out to another function inside the outer loop so we can stay focused on just one piece at a time. So we'll add a call to build properties and pass in the properties variable that we just defined. And then of course we'll need to build that function as well. Just like build types, we'll define ourselves a string builder up here at the top, and we'll append everything to that as we go along. We'll loop over the properties, pull each name out, and unless we find out otherwise, we'll just assume that each property's type is object. We'll add another try-catch in here. And we'll try to pull the property's type name out into a variable. There's a little replacement going on here because when you do reflection and you look at a generic type, it doesn't read the same as it would in source code. So we're going to look for this grave 1 left square bracket, replace that with a left angle bracket, and then we're also going to look for any and all right brackets and replace those with right angle brackets. Then we should be able to output our line here, which we'll copy and paste from an existing property just to make sure we get it all. And then we'll substitute the property type name where appropriate. This code simply loops through the properties and spits out that lazy backing field we created earlier. It does a little string manipulation to turn the generic properties into the right format for source code, change the casing of the property values to turn them into field names, and has some error handling built in case something goes wrong. I'll need to add the camel case method at the bottom of the script. This is a pretty naive implementation, but I'm banking on the fact that the properties had proper Pascal case names before, so this ought to do just fine. Regenerating the file gets us one step closer to the goal. We have a lot of errors about duplicate field definitions, so we can go to our existing builders and simply delete those now. There's still no build method though. I'm just going to paste this next piece of code in and talk about it rather than try and build it as we go. As with all of the other methods, we start with a string builder, which we add some boilerplate to. Then I've essentially copied in Country Builder's build method and replaced all of the property setting methods with another loop. After the loop, we close any braces or parentheses that were opened in the generated source and return the output of the string builder. The large number of spaces you see in the strings are a matter of trial and error. You just move things around until the generated code comes out the way you like. Before we go any further, we need to address that parent-child relationship fix-up code that we have in classes like State Builder. We can't really generate that relationship, at least not easily, and not with certainty that we're doing it correctly. We'll introduce a method called postBuild on the base builder class. It's a virtual method that does nothing, but you can easily override it on your half of the builder if there's any cleanup to do. It gets called as the last step of the build method before returning the completed object. Now we can delete the old handcrafted build methods that we worked so hard on, preserving the parent-child code in the postBuild method, which we'll need to do in State Builder. We'll just transplant this line from the old build method to the State Builder's postBuild method. If I rebuild now, I'll get some complaints related to the withObject methods in the existing builder classes. They reference the old private object field, and they're duplicates anyway now that they're being generated by the script. I'll just need to remove them from the existing builder classes. Regenerating the code now, we should have no errors, and the tests should pass as they did before. Let's look at what's left in the to-do list. The upper address builder partial class, remember that's the part we want to keep, has 3 factory methods in it: simple, typical, and Joe customer shipping. The lower partial class, that's the part we're trying to generate, only has the default factory method and a lot of with methods. These should be easy to add to the template. I'll update the script file to call out to a new method called buildDefaultMethod. It takes the builder name as its only parameter. At the bottom of the script, I'll need to define buildDefaultMethod. To stick with the convention so far, I'll declare a string builder and append content to it just for consistency's sake. This looks like all of the other methods. It has its generated code attribute. It's using string interpolation to inject the name of the builder class where appropriate, and then it returns the finished product as a string. If I rebuild the solution now, I will of course get some errors about duplicate definitions because the default method is now defined in more than one part of the partial classes. This is just the workflow when dealing with templated code. You create a coding pattern that works, you turn it into a template, and then you clean up any resulting duplicates. If you've built your template correctly, then the generated code should be a direct drop-in equivalent of the handwritten code you're replacing. In our case, we can check this by running the tests. And it looks like they're all passing, so our generated code works. The only thing left in the disposable lower partial class is the with methods. So let's fill them in and our generated partial builders will be complete. We'll start by adding one more method call to build types. We'll call this method buildWithMethods, and it's going to need the builder's name and the list of properties. Then we'll create the new method at the end of the file. I'll skip over the parts you've seen before. Here's our basic block for iterating over the properties, which you've seen before when we created the backing fields, and again when creating the build method. I've stubbed in the generated code attribute, so we're ready to start building the with methods. Remember that there are 3 of them. They'll all be called with something, where something is the name of the property it affects. The first takes in a simple value of the same type as the property. It then takes that value, wraps it in a lambda expression, and forwards it on to the second with method. The second method in the set takes a function whose return type matches the property and stores it in the lazy backing field. The third method is the without method, and it takes no parameters at all. It simply sets the lazy backing field to a function that returns the default value for that property. We can rebuild the solution, and the generated builders.cs file should now have all of the with methods. There's a minor typo in my script, which I'll clean up in a minute, but for now we can go to each of the existing builders and delete the entire lower partial class. I'll fix that missing semicolon and rebuild the solution again. What we're left with has eliminated all of the wiring under the board. Our half of the partial class is focused solely on what a valid state or country or address looks like, and not on how the builders operate. When a new model is added or an existing one modified, you only need to be concerned with the methods in your half of the partial. Since we're generating all of the boring parts of the builders now, let's look at the effort required to create a new builder from scratch. You can see that partial builders were automatically generated for every class that derives from model. If I wanted to fill out my half of a new builder, it would look pretty much like this. To keep this demonstration short, I'll create the manual half of the category builder class. I just need to add a new class in my builders folder called category builder. Then I'll mark the class as being partial. The only parts I need to build are any factory methods that I want, so I'll create the standard simple and typical methods here. and then I'll implement the post-build method to fix up the parent-child relationships. There are a couple of interesting things to note here. A simple category has a name, but no children. A typical category has anywhere from 1 to 10 children, all of which are made by calling simple. That way we don't fall into another infinite loop made of children and their children and their children and so on. I'm using the enumerable class here in two ways you may not see every day. Enumerable.range just gets you an enumerable with a given number of items in it. I'm using that list to project out a random list of children. In the post-build method, we're using enumerable empty to satisfy the for each loop when child categories is null, which is the case when you've started from the default factory method and not set the child categories property along the way. The point is that we've encapsulated this in the category builder so that no one else needs to think about it in their tests. You just ask for a typical category and off you go. Let's go replace all of the category mother calls with category builder calls. There aren't that many, and when I'm done, the tests will still pass, and I can delete the category mother entirely if I want at this point. In this module, we started by examining our handmade test object builders. We factored out everything we could into a base builder class. We divided off the interesting code into a partial class, and then we replaced the remaining formulaic code with a generated partial class by using C# scripts and the scripty.msbuild NuGet package. We've completed the journey from completely handmade test contexts to contexts that only draw attention to the parts that matter to the test. Future developers, yourself included, will have a much easier time reading your tests like the documentation that they are. There's nothing that says that object builders are inherently better than object mothers. You should use the one that makes the most sense to you and your team. I find object builders to be far more discoverable and more easily understood. There's also nothing that says my patterns are the only ones. Do a search for object mother or object builder and you'll find many different ways to accomplish the same tasks. Most that I've found use a single backing field, like my first iteration did at the beginning of Module 4. Don't feel like you're stuck with the pattern you started with either. My own builders have evolved greatly over the years. The lazy backing fields grew out of a particular need and then just became part of my pattern going forward. One of the great things about generated code is that if you make a change to the pattern, you only have to write it once, and all the separate implementations will get it on the next build. Consider leaving yourself hooks for further customization, like I did with the post-build method. For instance, in the hand-built version of WithCountry, we set up the country ID to match. And on WithCountryID, we blanked out the country property. I don't have an equivalent in the generated version we ended up with, but you could easily add virtual country-changed and country-ID-changed methods in the generated code, and call them from the with methods. This would give you additional hooks into the builder's lifecycle. If you have two properties that are dependent on each other, like country and country ID, you would just override those on methods and set or blank out the other property as appropriate. These are your classes, and you can do whatever you want with them. Leave me comments on the course discussion boards and share what you've done with others. I'd love to hear about it. Thanks for watching.